Vivek Sals and welcome to my YouTube channel. In this video, we start a new series of videos, and that will be computer vision with PyTorch. So, PyTorch is one of the machine learning framework and is based on Torch library and makes computer vision, natural language processing, and any other machine learning tasks or deep learning tasks like recommendation system very easier. So, from today, we'll focus on computer vision with PyTorch, and I'm assuming that you know a bit about computer vision background like PyTorch and PyTorch fundamentals like tensors and basic neural network stuffs. But if you don't know, and that too will slowly get to the to know about those stuffs too. It's going to have a good series to cover up and finish. So in this video, I'll be designing a very simple neural network to classify 10 different classes from a particular popular cipher 10 dataset. We'll be downloading it from Torch dataset hub, and so there will be no fancy loading of our custom dataset in this particular video, but don't worry, we'll do that for sure in the upcoming videos. However, before starting the code, we need to understand a bit about how we are going to approach this task. So what is ANN? So the figure you have, the figure you can see is a typical architecture of ANN, artificial neural network. So the first layer, these circular things are called the nodes. So these are the nodes, these are the input nodes, and the second layer, this is the hidden layer, and the third is the output layer. So in this figure I have just mentioned about three layers, but it could be three, four, five, six, any layers. So it all depends upon the architecture you are designing. And in this case we have just taken three input nodes, but as I mentioned, it can be as long as you want, or as bigger as your data desires. So you today in this video will be designing this neural network in PyTorch. So uh, regarding the dataset that today we are going to we are going to deal with, and this is the cipher 10 dataset sample. So it has 10 classes like airplane, automobile, bird, cat, deer, dog, frog, horse, sheep, and truck, and these are the random images. So what we need is we need to load this dataset, and we need to work on that. So this is a sample of dataset. So with each image of a airplane, we feed into the artificial neural network that I just showed. It generate a pattern for airplanes, like it has two wings, metal like body, and other specific. So we let the network decides what pattern to learn, and whenever new image is fed into the network, it analyzes the pattern in a new dataset and align with the pattern it previously learned and give us a probability result class. So what's next? We have already known a bit about artificial neural network. So in this, the approach we are taking to build this neural network is that we have images of 32 by 32 pixels, and it is a colored image, so three channels. So in total we have 3 by 32 by 32 dimensional image. So what we need is we need to feed into the input image. So for each node, it takes a single pixel. So what we need is we need to flatten those three-dimensional into one-dimensional vector. So 3 by 32 by 32 will be converted into or received into 3072 by one-dimensional vector. After that, what we do is we fade into this network, and in the next subsequent layer, we reduce the number of nodes, and in the final layer, since we have 10 classes to deal with, that it will the last layer will have 10 nodes, and it will be probability distribution, and the node which has the highest probability which will be labeled as a output from the network. So enough of the theory. I think it's time to go with the code. And for this I have open a new notebook file in Google Colab, and I think you know what Google Colab and how to open this. So let's type. So before proceeding to the code, let me remind you to just open a notebook in the Google Colab and start with me. So first, let's import the important library that is needed for our task. That is, first is import torch, second is import torch vision. So torch is for the main library of the PyTorch, and torch vision is a specific library that is for the computer vision tasks. And import torch vision that transforms as transforms. So this will for the transformation and augmentation of our images. Import torch dot nn as nn. So this torch dot nn is a base class or base library for all the neural network tasks. And import torch.optim as optim. So this torch.optim is for importing the optimizers. Import torch dot and then that functional as here. So since we have imported all this library and these all the functions of this libraries or the subclasses have been mentioned. So torch is the main library, torch vision is for the computer vision tasks, the transform is for transformation or augmentation of the images, nn as for neural network, and optim for optimizers, nn that functional for all the other required functional tasks. So kind of utilities. So after that we need to define our transforms. Ns transforms is equal to transform is equal to transforms that compose. So that is first is transform normalize 0.5 0.5 0.5 and another is, so let's copy this, that will be easier. So what this torch is, since the fighters or the tensor torch vision assumes the data to be in tensor. So tensor is nothing like a NDRF or numpy. So in torch that is a tensor. So it assumes the data to be in tensor. So we are converting the images to tensor, and after that we are normalizing it with a mean of 0.5 and standard deviation of 0.5. So since we are using 0.5, this is for the three channels. 0.5 will be used for all of the channels, and this 0.5 is for standard deviation to all the three channels. So let's run this cell. It's funny, right? We have mentioned about the transformation that is to be applied to the images, but we haven't even downloaded the images or dataset, right? So let's download it. Dataset is equal to torch dot datasets the CIFAR cipher 10. So the root will be dot slash cipher. So this will be the folder where the dataset will be downloaded. So train is equal to true, will only download the train part or the train part of this dataset, and transform is equal to transform. So all the transformation that we have mentioned here or defined here will be applied to the dataset, and after that what we need download is equal to true. So the data will be downloaded. So if you have the dataset in your local device, what you can do is make the download is equal to false parameter, and after that the loader part Let's create a data loader which loads the data from the to the data loader will load the data to the model in a certain batches. So for that, let's say torch.utils data loader data loader, and it will load data set that we mentioned here, and it will batch size will be 64, and shuffle is equal to true to create the randomness to the input of the data. And after that, it will download the dataset, and like it is downloading. And after that, what we need is we need to create a simple ANN architecture neural network. So let's close, we define it simple ANN, and it will be the sub module of ANN base class, which is the base class for all the neural network tasks. So let's init it. So every time the simple ANN class will be called, it will initializes this. So super simple ANN self dot. So what this line will do is every time we call the simple ANN, and it will initializes all the functionality or the all the things that this ANN that module has into this simple ANN, so that we can do all the neural network stops here. So let's um, for the initial layer, let's call it fully connected one layer, and in that linear. So since I already call, it will be 3 into 32 into 32 dimensional data that will be as the first layer of the simple ANN, and we convert that into second layer as only 128 nodes. After that, in the second layer, we project the 128 nodes into 64 nodes. So these are the arbitrary values how we normally like to define the number of nodes to the 2 to the power of something. So self that fully connected 3 is equal to nn that linear, and we project the 64 into, since we have 10 classes, so we project that into 10 classes. In this way we define the simple ANN or neural network in PyTorch. After that, what we need is we need to call a function or define a function for the forward pass. Forward, it will take self and x. This x will be the images. So what x will be is x that view -1 to 3 into 32 into 32. So this line is significant because x dot view means x dot reshape. In PyTorch we don't do x dot reshape, we do x dot view, and it -1 takes all the dimension to of the images that has into 3 into 32 into 30, that is 3072 dimension. So it is just a reshaping of the 3 by 32 by 32 dimensional into 1 into 3 into 1 into 3072 dimension. So after that, what we do is we pass into rectified linear unit, so it is activation function that is used to transform the input into and create the into the maximum of 0 in the input. So if we have anything value that is less than 0 in our input as input, then it will differentiate and only take the 0 or the maximum more than 0 positive thing, positive value. So this creates non-linearity to the model. So fc1x, and x is equal to again the ReLU activation function to the output of fc2. After that, what we need is x is equal to self dot fc3 x, and we return x. So in this way we define our class. So to instantiate it, we call it model is equal to, and model is equal to simple ann, simple ann. And we also need a certain loss function to calculate the difference between the output predicted value and the real level. So for that we define loss function criterion is equal to nn dot cross entropy as entropy cross entropy loss. And after, we also need optimizer to update the weight in regular intervals. So that in this case we are using optim dot stochastic gradient descent, and with it has the model parameters PARAMETERS model parameters, and the learning rate will be 0.0001. So this defines at what rate the weight will be updated. Momentum is equal to 0.9 is to accelerate the conversions. 0.9, sorry. Yes, now it's time to do the training loop in our um, the classification. So we need a training loop where we train the data. So we let's run for 10 epoch, or let's say 5 epoch, and for each in range epochs. So running, to calculate the running loss, I start with 0.0. Let's assume it has initial value of 0.0, and correct is equal to 0. So let's say we have 0 correct values, and total also 0. So each time we get the data in enumerate from data loader, and after that there are two values in the data loader output, that is inputs and labels. So what we need is we dispatch inputs and labels from the data. After that let's say optimizer dot 0 underscore grad. So that in every epoch sorry, there's mistakes. So in every epoch, first we let the gradient to be 0, and after that what we do is outputs is called, we feed the input to models, and it will give certain output, right? So after that we need to calculate the loss. So loss is equal to criterion outputs to labels. So these will calculate the difference between the outputs and the labels. LABE labels, and we lost it backward. So after that what we do is we can, according to the loss, we do back propagation and update the weight of the optimizer of the parameter OPTI optimizer. So after that what we do is we increment the running loss. It's called to loss dot item. So after that we have calculated the loss. After that what we do is we also calculate the accuracy, right? So to calculate the accuracy, what we need, predicted is called to torch dot max outputs dot data to 1. So what this line does is we take the outputs, and we only take the maximum node, the maximum probability. So in this way we take the predicted value, and after that we match it against the labels. So total, let's first add the total values and labels side 0. After that, what we need is we need to correct. It's equal to, so what this line does is it if checks if the predicted value is equal to the label, then it add up plus 1 to the correct number of correct values. And after that, if I is I percentage 100 is equal to 910 for every 100 mini batch, we are printing the values. Epoch, epoch is closed and this is also closed. Let's try. Okay, that's doing good. Let's hope it will cross 50%. Okay, so it was not able to complete the 50% mark, but we got 46.33% accuracy at the end, because this is a simple CN, this is a simple artificial neural network, and it doesn't have any complicated thing. We haven't done any transformation to the data so that it could learn more from this. So we use the vanilla type. In the next video, what we can do is we can build a more complex ANN with some kind of transformation in the data. And we also, in the upcoming video, we'll also deal with how to load your one one data set, custom data set, and make transformation to it. So much to cover in the upcoming videos, and I think I'll see you in the next video. And this